Good evening, student. Today my topic is classical theory of electric current. Already I have discussed about introduction of electric current by using qualitative and quantitative ideas. In qualitatively, I'll discuss about electric current like as the movement of charge carriers which represent electric current, and also in quantitatively the rate of flow of charge which represent electric current. And also already I have discussed about electric current is a tensor quantity. Why they becomes tensor quantity? Because it has magnitude as well as direction, but it could not obey the law of vector addition. It always obey the law of algebraic addition. That's why that become as a tensor quantity, or ଆମେ କହିପାରିବା scalar quantity. Okay? And its unit is ampere. Okay. Now in classical theory of electric current, if we assume a conductor and that conductor contains number of free electrons, in each cubic meter it has 10 to power 29 number of electrons per cubic meter. Okay, 10 to power 29 number of electrons per meter cube. That is cubic meter cube. Okay. Now that conductor which is placed inside the electric field, then what will happen? Already you know that electric field inside the conductor is zero. Why they become zero? If the conductor which is placed inside the electric field, then due to electric field the electrons which are placed inside the conductor, they are acquire some energy and they moves opposite to that of external electric fields, and they accumulate at a particular end of the conductor. In other end, the positive charge carriers are accumulated, or in other end the positive charges are accumulated. That's why the conductor again generates an induced electric field inside it due to external electric field. Therefore the electric field which is induced by the conductor, which is equal to negative of external electric fields. As we know that electric field is a vector quantity, that's why the induced electric field moves from positive to negative like that in that direction. Oppositely, external electric field moves in that direction. We know they are vector quantity, therefore the total electric field is zero. Clear? Which is only applicable in an isolated conductor. Clear? But some free electrons are there inside the conductor. Okay, are you getting my point? In an isolated conductor, the electric field intensity is zero. Clear? Now तुमरे doubt आस्तुबो सर इलेक्ट्रिक फील्ड टोटल इलेक्ट्रिक फील्ड इनसाइड द कंडक्टर जीरो हो गला सत सर से कंडक्टर भितर फ्री इलेक्ट्रॉन मोशन करुछंती ना रेस्ट अछंती ना नाहंती आसना ना पिले क्वेश्चन मु कहबी इलेक्ट्रिक फील्ड इंटेंसिटी 0 हिला सत किंतु ए कंडक्टर भितरे अनेक गुड़ाए फ्री इलेक्ट्रॉन अच्छा से मैंने कौन कर भाइब्रेट कर एंड दे आर मूविंग विथ जिगजैग मोशन कोई हिसाब से रैंडमली मूव कर with some velocity, that is velocity of electron, that is EV, velocity of electron inside the conductor is 10 to power 5 meter per second. Each electron moves with velocity that is 10 to power 5 meter per second. Again, in your mind, some question arises, that is how they are arised, sir? How they are vibrating, sir? Because that conductor always placed at room temperature, so they acquire thermal energy. Due to thermal energy, they are vibrating in zigzag motion with some velocity that is about 10 to power 5 meter per second. Clear? Now okay, if that conductor which is connected by an battery through the wire, then what will happen? In that case, the charges which are accumulated to end of the conductor becomes gradually decreases, because that is positive and that is negative. If you assume that is V volt and that is 0 volt, if you assume, the negative becomes as a 0, positive becomes as a V volt. That means आम जब देखिबा जदि 12 volt दिया जाउची, that is 10 volt, एटा होची -2 volt. Okay, so add कले केतला V2 minus V1, that is 12 volt, 12 volt, 0 volt, 12 volt. Okay, so that is V volt, so that is positive volt and that is negative volt. That's why the number of electrons which are accumulated, there becomes flowing inside the through the wire. They are flowing through the wire. Similarly, the positive charges are also flowing through the wire. That's why the accumulation becomes stopped and it becomes, the electric field gradually decreases, but it not be 0. Okay, if you assume in that topic, that is electric current, when the conductor which is connected to a battery, then the electric field is there inside the conductor. It means inside the conductor some electric fields are there, but in electrostatic, when we apply electric field, then there is no electric field inside the conductor. Again, I will repeat that thing. When we connect a battery to that conductor, electric fields induced in that conductor, okay, that not be 0, but the electric field inside the conductor cannot be 0. Clear? It has some value, but in electrostatic it has 0, so it is an isolated conductor. But in that case, this is not an isolated conductor. Clear? Because it is connected to battery by using wire. So that is negative charges E, E, okay. So there is a current which is generated opposite to that of electron. We know that electron always moves from lower potential to higher potential, but current moves from higher potential to lower potential along the direction of electric fields. Because when we connect the battery to that conductor, that is positive and negative potential becomes created across two ends of the conductors. That's why they generate an electric field. Clear? So that the electron moves opposite to that of electric field. That's why the current also moves opposite to that of electron. So that electron always moves from lower potential to higher potential and also opposite to that of electric field. But electric current which moves from higher potential to lower potential along the direction of electric field. Okay, this is overall view of classical theory of electric currents. Clear? Thank you.